Hello, welcome to Basic 2 Tech for students, teachers, and math education. Today we have an exciting topic to delve into calculus. We will explore its historical background, fascinating applications, and its immense importance in various fields. If you want to know why you study calculus, then stay tuned. To understand the background of calculus, we need to go back to the late 17th century when two brilliant minds, Sir Isaac Newton and Gottfried Wilhelm Leibniz, they solely developed the foundations of this mathematical discipline. Newton developed calculus to explain the laws of motion and gravitation, while Leibniz's motivation was more focused on optimization and areas under curves. Their groundbreaking work revolutionized mathematics and set the stage for modern calculus. It allowed for a deeper understanding of change, motion, and the connection between quantities. Calculus is built on two pillars: differential calculus and integral calculus. Differential calculus focuses on rate of change and slopes of curves. It helps us answer questions like how fast is an object moving at specific moment, or what is the rate at which a function is changing. On the other hand, integral calculus deals with accumulation and the concept of area. It helps us calculate areas, volumes, and solve problems involving accumulation or summation. Now, let's explore the applications and importance of calculus in various fields. First, in the realm of physics, calculus is indispensable. It allows us to describe the motion of objects, analyze forces and energy, understand waves and oscillations, and delve into the principle of electromagnetism and quantum mechanics. Engineers heavily rely on calculus. They use it to model and analyze complex systems, design structures, optimize different processes, and solve differential equations in heat transfer and fluid dynamics. They also use calculus to design electrical circuits. Calculus is the backbone of many engineering disciplines. In the realm of finance and economics, calculus plays a vital role. It helps economists model and analyze economic systems, optimize production and consumption decisions. It also helps in study of interest rates and understanding the concepts of derivatives and integrals in financial mathematics. Do you know that calculus is a powerful tool for predicting and understanding economic trends? Calculus also finds application in biology and medicine. It aids in modeling population dynamics, studying biochemical reactions, analyzing psychological process, and understanding medical imaging techniques like MRI and CT scans. Calculus allows medical professionals to make accurate diagnosis and devise effective treatments. Even in the realm of computer science, calculus plays a crucial role. It is used in image and signal processing, data analysis, and machine learning algorithms. It is used in computational geometry, computer graphics, and simulations. Calculus enables computers to process and analyze vast amounts of data efficiently. So, whether you are exploring the depths of the universe, designing innovative structures, analyzing economic trends, or developing cutting edge technology, calculus will be your trusted companion. It provides us with the tools to understand change, optimize processes, and solve complex problems. That is all for today. I hope you enjoyed this journey through the historical background, applications, and importance of calculus. If you found this information fascinating, make sure to hit that like button, subscribe, and share this video with others. See you in the next video.